Yes, good morning to my dear friends, and also welcome to electronics online classes. Look here, in the last class we are discussing about the differential amplifier and also different configurations, and today we'll go for another small thing in that differential amplifier, that is how we can operate, what are the different modes of operation of the differential amplifier. And before that, as usual, we'll recall what you studied in the last class, and maybe today is the lecture number 3. Today we going for the lecture number 3, and going for the different modes of differential amplifier. Different modes of differential amplifier. Look here, as you know already, you have studied in last class, the differential amplifier is an hot up and operational amplifier. The differential amplifier is an hot up and operational amplifier. It means in every operational amplifier we are having the differential amplifier, and basically your op-amp is a differential amplifier. And as we know the definition of differential amplifier, it is an amplifier, but it will amplify the difference between the two signals. What is differential amplifier? It is a type of amplifier, and it will amplify the difference between the two signals, and that is nothing but your differential amplifier. And also, as I said, why you are using the differential amplifier and what is the importance of differential amplifier? By using the differential amplifier, we can reduce the noise. Also, we can reduce the distortions. By using the differential amplifier, we can reduce the noise as well as we can reduce the distortions. That is about the differential amplifier. And also studied about actually there are you can connect there are 4 configurations depending upon the how much you apply the input and how much you apply the output. And we have studied about the 4 types of different configurations of differential amplifier. One is called dual input and balanced output, and also discussed about the dual input and unbalanced output, and also studied about single input and balanced output, and finally we studied about the 4th one, that is something called single input and unbalanced output. Look here, in this you have studied already about the working principle of dual input and balanced output differential amplifier. And actually I just said before, this differential amplifier can be operated in 2 ways. This much you studied in the last class. Actually, as I said, the differential amplifier is a type of amplifier. It will amplify the difference between the 2 signals. And the important thing, it will reduce the noise as well as it will reduce the distortion. That is about yesterday's class. And also today we'll go for what are the different modes of operations. It means the differential amplifier can be operated in 2 modes. The differential amplifier can be operated in 2 modes. The first mode is called the differential mode. The differential mode of operation. You can write mode of operation. The first one is differential mode, and second one is the common mode. Common mode of operation of the differential amplifier. It means the differential amplifier can be operated in two modes. One is called the differential mode, one is called the common mode. And we go for actually how we can operate in differential mode and what is called differential mode, also called what is called the differential mode gain and what is called common mode gain, and how actually your differential amplifier can be operated in differential mode or maybe the common mode. You look here for your first we go for the differential mode. Actually, as we know already, in your differential amplifier we are having the two inputs. We are applying the two inputs and also we may get two outputs and we may get single output. But especially if you are going for the differential amplifier, you are studying about the dual input and balanced output differential amplifier. In the dual input and balanced output differential amplifier, you are studying about the operating in the differential mode and common mode. In your differential mode, we are applying the inputs. We are applying the V1 and V2. Actually, in the differential mode, you are applying the different inputs. We are applying V1 and V2, they are different. And what is called the differential mode of operation means in the differential mode of operation, you are applying the inputs. The input are in you are applying the input voltage. The voltage are not equal. Okay, I repeat. In the differential mode of operation, we are applying the inputs. That inputs are not equal. That inputs are not equal. Also, that inputs are not in the same phase. You are applying the different amplitudes of the input voltages. You are applying the different amplitudes of the voltages. It means in your differential mode of operation, the V1 is not equal to 0 and also V2 is not equal to 0. It means if you are applying the different voltages in your differential amplifier. In your differential amplifier, you are having the two inputs. The one input is different from the other input. It means both the inputs are not same. You are applying the different inputs to the differential amplifier. And as we know already, the differential amplifier will amplify the difference between the two signals. The differential amplifier will amplify the difference between the two signals. It means as we know, you are applying the two inputs and also arrive the two outputs. And as we know, the V01, the output 1 is equal to the, yes, we know already the AD, nothing but the voltage gain is equal to the V1 minus V2. The voltage output voltage is nothing but the voltage gain, the differential gain to the V1 minus V2. Or we can write about this is about the V01 and we can write about V02, that also AD into V1 minus V2. It means in your differential amplifier, they will amplify the difference between the two signals. The differential amplifier will amplify the difference between the two signals. As you know the basic equation, what is the basic equation? The differential gain is equal to V0 by Vin. But here the Vin nothing but you are applying the two inputs. It means we can write about V0 equal to V1 minus V2. I can cross multiply V1 into AD equal to V0. That is your equation. This is for the output 1, this is for the output 2. It means as we know already, if you apply both the inputs simultaneously, it is not possible to find out the output simultaneously. That's why what we do, as you studied about in the time of the working of dual input and balanced output differential amplifier, you consider only one input and the remaining you make it ground. And another time you take another input and the remaining you go for the make it ground. And finally, if you apply the superposition theorem, then we can add both the inputs. By the use of superposition theorem, by the use of superposition theorem. What do we get? Yes, by the superposition theorem, by the superposition theorem, what we can write? Yes, as you know, the AD, the differential gain is equal to the V0 by V1 minus V2. This is the important about the differential gain is nothing but the output to the input. But as I said, in your differential amplifier, you are applying the two inputs. You are applying the two inputs, V1 minus V2. And as you know, if you apply the superposition theorem, and practically what you get the AD, nothing but the AD nothing but differential mode. The differential mode we can also write the AD nothing but the differential mode gain. It is nothing but V0, the differential to the V in differential. Or finally we want if we apply the superposition theorem, and what is called our differential mode gain. The differential mode gain AD equal to, yes, we get the minus RC divided by 2RE. Actually, you are not having any derivation for this. Directly they are given the equation. By this equation, you can conclude the differential mode gain. The differential gain is equal to the minus RC by 2RE. It means in simple way, don't confuse. In the differential mode, we are applying the two different voltage to the inputs. It means you are not applying the same voltage to the V1 and V2. And as we know the basic property of your differential amplifier, the differential amplifier will amplify the difference between the two signals. And finally, as we know, you are finding the gain. The gain is nothing but output to the input, and you are finding the differential mode gain. You are finding the differential mode gain. The differential mode gain is nothing but V0 by V1 minus V2. And you can write V0 differential to the V in differential. And if you simplify this, you get the minus RC by 2RE. This is the final equation of your differential mode gain. It means, as we know, in your differential amplifier, you are having the two inputs, also you are having the two outputs. And because of two inputs, you can apply the same input or you can apply different inputs. For your differential mode operation, you are applying the two inputs are different. It means you are applying the different voltage to the inputs. You are applying different voltages, you are applying different magnitudes, you are applying different amplitudes, also they are having a different space. That's what happens. We will get finally we get AD nothing but the differential mode is equal to the minus RC by 2RE. We get the differential mode nothing but RC by 2RE dash. The differential mode, the finally we get RC by 2RE dash. This is about the differential mode. It means in differential mode we are applying the different inputs, and the different inputs will be amplified, because as with the property of differential amplifier, they will amplify the difference between the two signals. This is about in simple way of your differential mode gain. The differential mode gain nothing but output and input, and as you know, you are applying different inputs. It means you are applying two inputs. The two inputs will be difference of two inputs be amplified. This is about the differential mode of operation. And now we go for the another one, that is called your common mode operation. That is called your common mode of operation. Look here, as we know, now is said in your common mode of operation, as once again in your difference amplifier, you are having the two inputs, also you are having the two outputs. And in the differential mode, you apply the two inputs are different, but here you take their name and it is common. Common means you are applying the both inputs are same. You are applying the both inputs are same, or you are applying same input to the both the inputs. You are applying the V1 and V2 are equal. You are applying same input or you are applying the same inputs to the two terminals of your differential amplifier. It means in the common mode of operation, the V1 is equal to V2. It means in your common mode of operation, you are applying the inputs are same. It means you are applying the same input to the both the V1 and V2. And as we know, if you are applying the same input to your common mode operation, what will get the output? 100% the output will get the 0. And why will get the output 0? Because as we know, we are studying about differential amplifier. The differential amplifier will amplify the difference between the two signals because you are applying the same signal at the inputs. That's why what happens? The output will be 0. Because what happens? Because you are applying the same inputs to your differential amplifier. Because of you are applying the same input to the differential amplifier, the output will be 0. Because as we know, the V01 equal to is ED into V1 minus V2, or we can write V02 equal to AD V1 minus V2. It is here the overall the input is 0. That's what happens. The V01 is also 0, V02 also 0. And as we know already, in your differential amplifier, you are using the two transistors. They are in the same time. In differential amplifier, you are using the two transistors. They are in the same time. And because of you are using the two transistors, also you are applying the two input voltages. You are applying the two input voltages. Because of if you are applying two input voltages, that input voltage will drive both the transistors. You are applying the input voltages for Q1 as well as Q2. If you are applying the same voltage for Q1 and Q2, and what happens? Because of you are applying same input and also you are using same type of transistor, what happens? Because of your emitter is common for both the Q1 and Q2, what happens? The emitter current increases. The emitter current increases, or the voltage across the emitter will be increased. And important thing is that if you are, as we know, if you apply the superposition theorem, once again if you apply superposition theorem, and also as we know, if it is not possible to apply both the inputs simultaneously, if we consider only one input and one output, then what happens? Actually, in the outputs, what happens? If you apply the common mode signal to the inputs of a differential amplifier, in the output V01 and V02, they are in the opposite phase. The output are in the opposite phase. As in your common differential mode, both the V01 and V02 are in the same phase. But because in the common mode, what happens? You are applying the common signal. You are applying the same input to both the terminals of the input. That's what happens. The output voltage will be out of phase. It means V01 and V02 they are in the out of phase. The V01 and V02 are in the out of phase. It means in the overall, because of V01 0, V02 0, what happens? The common mode gain also 0. I am saying theoretically the common mode gain also same. As we know the common mode gain, how you have done the differential mode in the same way over the common mode. In the common mode is equal to same V0 common to the V in common. It means as we know you are applying the same inputs. Once again, as we know AC equal to V0 by V in minus V2. Because it what happens? You are totally the common mode gain is 0. Because you are applying the same inputs, and especially the differential amplifier oppose the common mode operation. Usually the differential amplifier will opposes if you are applying the same input voltage. And once again, if you use the superposition theorem, and as I said, if you consider the alone, you are considered only one input, in that time what happens? The both the output voltages, the V01, the V01 and V02, they are in the out of phase. The output voltages V01 and V02 are out of phase. And also finally, if you apply the superposition theorem, then what happens? The AC equal to minus RC by 2R. This is your actually, as I said, theoretically you get the 0. The common mode gain is 0, but practically you get the minus RC by 2R. This is also you are not having the derivation. Only exam they will give the, it is not therefore syllabus to go for the derivation. Only directly they will take the equation for your common mode of operation. The common mode gain is nothing but minus RC by 2R. And as I said, why you get minus sign? Because they are both the voltages. Your output voltages are in the opposite phase. And also, as if you go in deep, means you are using the common emitter, and whatever the voltage drop across your emitter is, that will give the negative feedback. Because of negative feedback, also you get the minus sign for the common mode. This is about in simple way of your we can operate the differential amplifier in two modes. One is called differential mode, another is called the common mode. Very simple. In the differential mode, you are applying the different inputs. You are not applying the same outputs. Sorry, you are not applying the same inputs. Because of you are not applying same inputs, what happens? And also, as we know the property of differential amplifier, the differential amplifier will amplify the difference between the two signals. Because that is what happens, in the differential mode, the V01 is not equal to 0, also V02 is not equal to 0. And finally, if we use the superposition theorem, and as we know, we get the AD equal to, yes, AD equal to RC by 2RE dash. This is about the differential mode gain, and this is nothing but the common mode gain. It means, as we know, gain nothing but the output of the input. And if the output is same, or it may be common mode or it may be differential mode, but in common mode, because you are applying the same inputs, the output mode will be 0. But because of the in the differential mode, you are applying the different inputs, that's why you get the output. And output are not same. But in common mode, the both outputs are same. This is the mode in simple way of your you can operate the differential amplifier in two ways. One is called differential mode, another is called the common mode. And this is about in brief about your differential amplifier. Now we will go for once again because our aim, our topic is about operational amplifier. The important thing, we are giving more importance to the operational amplifier. Why you studied about differential amplifier? Because it is so important. As I said, it is the heart of an operational amplifier, and also it is the initial stage or it is the input stage of an operational amplifier, and also basically your application differential amplifier. Basically your application differential amplifier. Now we will go for the symbol of your amplifier. Actually, as we know already, you studied in detail about the operational amplifier. As operational amplifier is a direct coupled high gain differential amplifier in simple way. And if you go in deep, the op-amp is a direct coupled high gain, high input impedance, low output impedance, and high bandwidth differential amplifier. This is you know already, and also I said in the last classes why it is called op-amp, because you will do the method of operation such as addition, subtraction, multiplication, differential integration. That's what is called as your op-amp. Now we will go for what is the symbol of your op-amp. What is the symbol of your op-amp? As we know, every instrument, every device has their own symbol. And here in your op-amp, you are having the 5 important terminals. You are having the 5 important terminals, and here the IC 741. You are studying about the IC 741. The symbol for op-amp is about this pin number 2, pin number 3, and pin number 6. And here we are applying pin number 7 to the positive VCC and pin number 4 to the negative VCC. And here I will write once again the pin number 2 is called inverting terminal. Inverting, and pin number 2 is called non-inverting. And pin number 6, the pin number 2 and pin number 3, and important thing, pin number 6 is output voltage. Always you can measure the output across pin number 6, and especially in your op-amp, the pin number 2 and pin number 3 are the inputs. As we know, in your operation amplifier, basically it is a difference amplifier. That's why having the 2 inputs, and output may be 1 or 2, but inputs are common, that is only 2. Output may be the 1, output may be 2, but in overall in your op-amp, you are considering the output is only 1. It means you are considering the, in op-amp you are considering the dual input and unbalanced output operation amplifier. It means you are having the 2 inputs. The pin number 2 is called inverting terminal, and pin number 3 is called non-inverting terminal, and pin number 6 is called output. Always you measure the output across pin number 6. Whenever you are using the IC 741, always you are measuring the output across pin number 6. And if you want to apply the any input voltages, pin number 2 and pin number 3 acts as input voltages. And pin number 2 is called inverting terminal, pin number 3 is called non-inverting terminal. And as usual, you are studying the different types of amplifiers. In your all the amplifiers you are studying, you are applying only the positive VCC. You are applying only the positive VCC. But the speciality of your operation amplifier, you are applying, it requires the positive VCC as well as negative VCC. It means in operation amplifier you want both voltage, you want the biasing voltage, the positive as well as negative. In general, you have done so many experiments, you have done so many amplifiers, we require only the positive supply voltage. We require only positive supply voltage. But only for the operation amplifier we require both. We require the positive voltage as well as we require the negative voltage. We require positive voltage as well as we require the negative voltage. And the important thing, as you studied in your basic, if you want to the positive voltage, as we know, you are using an IC, that is your 7812, they will give the positive voltages. If you want 12 volts, you are using the IC, if that will give the 7812, they will give the positive 12 volts. If you want minus 12 volts, that is 7912, they will give the minus 12 volts. And maximum in operation amplifier, you can apply the supply voltage, that is 12 to 18 volts. You can apply the 12 to 18 volts. That is plus 12 volts to minus 12 volts, and plus 18 volts and minus 18 volts. You are applying the same voltages. The positive VCC and negative VCC are same, and minimum apply 12 volts, maximum apply the 18 volts. It means the most important property of operation amplifier, the operation amplifier requires both the voltages. It requires the positive voltage, also it requires the negative voltage. And let me ask the question, sir, why it requires both the voltages? Because as you know already, in the time of working of the dual input and balanced output difference we have studied, the differential amplifier, it contains the two transistors Q1 and Q2. And as we know, if we apply the inputs, what happens? The Q1 acts, sometimes Q1 acts as a C amplifier, and sometimes the Q2 acts as a CB amplifier, and sometimes the Q1 acts as a CV amplifier, and sometimes the Q2 acts as a amplifier. It means in overall, in simple way, your difference amplifier acts as a both common base amplifier, it also acts as a common emitter amplifier. And as we know, in common base amplifier, we want the negative voltages. We want the negative voltages. That's why we are applying the positive voltage as well as the negative voltages. This is one simple reason. Another important reason. Actually, why it is called inverting terminal? Why the pin number 2 is called inverted terminal, and why the pin number 3 is called non-inverting terminal? Inverting is, their name indicates, invert. It means whatever you apply the input to the this pin number 2, that is inverted. It means if you apply the some voltage to the inverting terminal, that voltage will be inverted. It means the input and output are in the 180 out of phase. If you apply the input to the inverting terminal, then what happens? The output will be 180 out of phase. Because in that time your op-amp acts as a C amplifier. In that time your op-amp acts as a C amplifier. At the same time, if you apply the input to the non-inverting terminal, then what happens? The input or output in the same phase. The input or output in the same phase. And in this case, it acts as a common base amplifier. In this case, it acts as a common base amplifier. It means why we get if you apply the input to the inverting terminal, we will get the output. The input or output in the 180 out of phase. But in the same time, if you apply the input to the pin number 3, non-inverting terminal is the input output in the same phase. Their name and their meaning. Inverting with invert, they invert the signal. For example, if you apply the input like that, then what will get the output? The output will be inverted. Like that, you get the output. For your inverting, this is for the inverting mode of operation. If you apply the input, this is your input and this is your output for the inverting. It means because of the property of your difference amplifier, and in the difference amplifier having the sometimes it acts as a common base, sometimes it acts as a common emitter, and whenever you apply the input to the pin number 2, that time it acts as a C amplifier. It means the input output in the 180 out of phase. If you apply the AC voltage, what happens if you apply DC voltage? For example, if you apply the 2 volts, you get the minus 2 volts. I am saying in general, and if you apply or if you amplify, you may get minus 4 volts. I am saying in general, and that means if you apply DC, you are having the inverted, you are having positive everything. And also I said another important application of the op-amp is used as a sign changer, plus minus. And the same time, if you go for non-inverting, then what happens? If you apply the AC signal, then you get the same, but amplified. Here also, if you apply input, that signal amplified, but they are in the out of phase. But here in the non-inverting, they are in the same phase. Whatever is applied input, that is coming same, but it is amplified. It means in the inverting, if you apply the input inverting terminal, then what happens? Input or output in the 180 out of phase. At the same time, if you apply the input to the non-inverting terminal, then what happens? The input output in the same phase. The input output in the same phase. That is because of your differential amplifier acts as a common base amplifier. And also here also you are not, if you apply 2 volt, you get 24 volts. You are not having any change of the sign because it is non-inverting. It is not inverting the signal. It is inverting the signal. This is about the symbol of your operation amplifier. The important thing is about always whenever you are using IC741, you are measuring the output across pin number 6. And if you want to apply input, it may be pin number 2 or it may be pin number 3. Pin number 2 is called inverting terminal and pin number 3 is called non-inverting terminal. And always whenever you are using your op-amp, we require the positive voltages as well as require the negative voltage. And that voltages are same. And also they are given the minimum range 12 volts to the 18 volts, some they are given 20 volts also. This is about in brief about your symbol of your operation amplifier. Now we look for last final, that is so important in any amplifier. What are the important characteristics of operation amplifier? The important characteristics of op-amp. As we know already, you have studied the different types of amplifiers. It may be single stage, or it may be multi-stage, or it may be power amplifiers, or it may be a feedback amplifiers. In the all the amplifiers are given more importance to the what are the most important characteristics, or what are the most important parameters of your operation amplifier. What are the most important parameters, or what are the most important characteristics of your operation amplifier? They will ask for 2 or 3 mark question. Explain the different parameters or different characteristics of your operation amplifier. The first important characteristic, that is about open loop gain. That is about open loop gain. This also I said in the time of feedback amplifiers. What is called open loop gain? The gain without feedback. The open loop gain nothing but the gain without feedback, and gain with feedback is called closed loop gain. It means the first important property of your characteristics of operation amplifier, that is open loop gain. What is open loop gain? Nothing but the gain without feedback. The gain without feedback. As we know, open loop gain is equal to V0 by V. And as usual in your operation amplifier, as I said, ideally it is having the infinite open loop gain. But as we know, no one is ideal, and it is not possible to construct any ideal device. And because every device has some drawbacks and limitations, and in general also no person is ideal, only the God is ideal. Remaining every person, every device having some limitations and drawbacks. In the same way, for our operation amplifier also some limitations and drawbacks. That is why ideally you have infinity, and also as I said, it is not possible to construct an ideal operation amplifier. Practically it is not possible. We can say theoretically, ideally it is infinite. It means for open loop gain, nothing but gain without feedback, and ideally it is infinite, but practically it is nearly about 10⁵. It is nearly about 10⁵. It means we are having very more open loop gain. We are having the very more open loop gain. That is about the first important characteristics. Next, we go for the another one important characteristics. As we know already, in every amplifier we are studying about this. That is nothing but the second one, the input impedance. That is input impedance. That is nothing but input impedance. What is called input impedance? As we know, the input impedance is nothing but the impedance offered by the input terminal. The impedance is nothing but the opposition offered by the input terminal. Right up. What is called input impedance? Input impedance is nothing but the impedance offered by the input terminals. And as usual, as we know, in general, they want more input impedance. Always they want more input impedance. And in why we prefer op-amp? Because it is having the more input impedance. And usually, as we know, you are measuring the input impedance in megaohms. In megaohms. That is practically, and ideally it is also infinity. Ideally it is infinity. The input impedance is infinity, but practically it is some megaohms. There are some very more input impedance. And as I said, ideally it is infinite. As I said, it is not possible to construct an ideal device. That's why the input impedance is very more. And as we know, always we require more input impedance. Why we require more input impedance? Because it does not affect the your voltage and current source. It is not affected by the loading effect of the previous stages. It is not having the loading effect of previous stage. That's why we want more input impedance. And at the same time, we go for the output impedance. The third one is about output impedance. Here also same. What is output impedance? The impedance offered by the op-amp to the output terminals. the impedance offered by the op-amp to the output terminals. That is nothing but impedance or opposition offered by the op-amp for the output terminals. That is something but output impedance. And as we know, in general, we want very low output impedance. We want very low output impedance, but ideally zero. Ideally zero, but in your op-amp arrive very low output is maybe some ohms, maybe some 10 ohms or something. Means can I say some ohms, low ohms. And as we know, we want always very low output impedance. Why we want very low output impedance? To drive the more devices output. To drive the more devices output, we want the very low input. Low output impedance. Although it is also does not affect the loading effect of the previous cases. It means output impedance is nothing but impedance offered by the output terminals, and in general we want very low output impedance, and ideally is zero output impedance. The op-amp will give low output impedance, nearly every for some 10 ohms or some various ohms, but ideally is zero. Practically it is not possible to make it zero, having some ohms. This is about the output impedance. Then you go for another property, that is nothing but your bandwidth. That is nothing but your bandwidth. Yes, I just said so many times. For your in general, we want your bandwidth. What is bandwidth? The bandwidth nothing but the range of frequencies, the band of frequencies. What happens? The gain will be constant. The gain will be constant. Or in another way, simple way, the bandwidth nothing but the band of frequency, range of frequency. The amplifier will amplify the signal faithfully. For the example, some 0 to infinity or some 0 to some megahertz, our gain should be constant. Or our op-amp can amplify very low frequency to the very high frequency. Or for example, very low means 0 to some megahertz or 0 to infinity. Actually, in general, as I said, theoretically it is the practically it is some megahertz, but ideally having infinity. Ideally, the op-amp having an infinite bandwidth, but it is not possible for practically we get some megahertz. The bandwidth is some megahertz. It means what is bandwidth? The band of frequencies, the gain will be constant, or the how much frequency range your amplifier will amplify signal. That is faithfully. That is something but your bandwidth. And these are the common characteristics of your all the amplifiers. But there are three important characteristics. They are so important. They are not there for in general operation. In general amplifiers. First one is called maybe the fourth one is called common mode rejection ratio. It is also called as CMRR. It is also called as CMRR. It's so important characteristics, so important. It is not there in your remaining amplifiers. Only it is there in your operational amplifier. That is called common mode rejection ratio. CMRR nothing but common mode rejection ratio. And they will ask you one more question. Define CMRR. The CMRR nothing but common mode rejection ratio. And how we can define? It is a ratio of the differential gain to the common mode, ED by AC. We can define the CMMR. It is the ratio of the differential gain to the common mode gain. It is the ratio of differential gain to the common mode gain. That is nothing but your CMRR. Actually, here also we want ideally it is infinity, but practically having 90 degree. Practically 90 degree. It is what is the importance of CMMR? The importance of CMRR, always we want more CMRR because it is having the property of to reject the common mode signals, and the common mode signal may be the noise, it may be the distortions. It means if you are having very high CMRR, that is nothing but your amplifier will amplify the signal very good. The CMRR indicates ability of an amplifier. The CMRR indicates the ability of an amplifier. How much the ability of the amplifier to amplify signal. Always we want CMRR, that is infinity ideally, but it's practically having the 90 dB. It means the CMRR nothing but it is the ratio of differential mode gain to the common mode gain, or you can write DIF, differential mode to the common mode gain. And as we know, we can write it in the decibels. CMRR in decibel is nothing but 20 log ED by AC. 20 log ED by AC. This is about the another important property of your op-amp, that is common mode rejection ratio. It is called CMRR. It is the ratio of the differential mode gain to the common mode gain, and ideal is infinity, but practically it is 90 dB. And as we know, the importance of property of CMRR is nothing but it is having the ability to oppose or the reduce the noise as well as the distortion. Whatever the common signal that appear across the inverting non-inverting terminal, that will be reduces opposed by the this important property of your op-amp. This is about the common mode rejection ratio. And finally go for another one important, that is about the slew rate. That is about your slew rate. That also is important characteristics of your maybe 5x. That also important about your studying your different types of yes, you are studying about slew rate. This is also important. And what is the importance of slew rate? This is also the last one question. The slew rate you can write SR equal to it is the ratio of the small change in the slew rate, nothing but it is the ratio of the maximum rate of change of output with respect to the input. Once again repeat, what is slew rate? It is so important characteristic of the operation amplifier. The slew rate, how we can define the slew rate? Nothing but the maximum output voltage with respect to the input voltage. The maximum rate of change output voltage with respect to time. The maximum rate of output voltage with respect to the time. Or in simple way, how we can say about slew rate? The slew rate will give the ability of the op-amp, how much fast the output will change with respect to input. What is slew rate? The how much fast the output will change with respect to input. That will give the information about the slew rate. Or you can say the maximum output voltage, the ability of the output voltage changes with respect to time. That is given by your slew rate. And actually the slew rate you can measure by volts per microsecond. That is nearly about 0.5. That is nearly about 0.5 microsecond. And this also ideally is also slew rate is also infinity. But we get practically 0.5 microsecond. It means the slew rate indicates how much fast your output will change with respect to time. Or you can say this also say the ability of the op-amp, how much fast the output will change with respect to input. That is nothing but your slew rate, and it is measured in volts per microsecond, and ideally it is infinity, but practically it is 0.5 microsecond. This is about in simple way of different parameters or different characteristics of your operation. Thank you.